Hi guys, this video is going to be on graphing exponential growth functions. This is one of two videos. This is part one. So we're going to take a look at the parent graph of an exponential growth function and how to transform it. So using our A, H, and K values. So what we'll do first is just remind ourselves what an exponential growth function looks like. So if we're going to use y equals, you can also do function notation, totally up to you. But I'm going to remind ourselves that y equals b to the x power is kind of like our base function. This is without any transformations. It's just some number raised to the x power. Now with transformation, it's going to look a little different. We're going to write the same function, but we're going to have some values included, just like with any other function that we transform. So with transformations, we'll have an a value, we'll have b to the x minus h, and then we're going to have plus k. So you'll notice you might recognize these values, and they're in similar places that they are in a lot of other transformed functions. So let's kind of talk about why each one of these values is important or how it pertains to today's lesson, and then we'll graph a parent function. All right, so the first thing we have is our a value. That's this number right here that's multiplied by this value. And this tells us a little bit of information about reflections and stretches and compresses vertically. So if a is less than 0 or a negative number, we're going to have a reflection across the x-axis. The other information it tells us is about the vertical stretch or compression. So we're running out of room a little bit, but I'm just going to say stretch or compress vertically. For today, we're not going to have a value multiplied by b. B is our base value. So for this part, we're just going to write base value. So that could be any whole number for today's lesson. So 2, 5, 10, 20, any whole number. H, just like with any other function, is going to affect our graph in the horizontal direction. So this is going to be a shift to the right or to the left. If you want to write horizontal shift, that's also totally fine. And then the last value is our K value, and this is also a shift, but this is going to be up or down, or in other words, you could say a vertical shift. So with these values and with some rules that I'm about to give you, we're going to be able to graph transformed exponential growth functions. Last really important value or piece to an exponential growth function is the asymptote. So this is the line that our graph is going to approach but not touch. So we'll kind of define that and then show it in our graph. So this is the line the graph approaches but doesn't touch. Kind of acts like a barrier, but one that kind of pulls the graph towards it. So you'll notice anywhere where there's an asymptote near some graph that you're drawing, your graph is going to be really, really, really close to it, but it's never actually going to touch it. And then our asymptote for our parent function is going to be y equals 0, but when we transform it, it's going to be y equals k. So the reason that our asymptote is at the line y equals k is because k drags our graph up and down. It's a vertical shift. So if our parent function has an asymptote on the x-axis, then the only way it changes is if we shift up or down. So your k value is your new asymptote. All right, with that all in mind, let's take a look at one example of a parent function. Now there's a ton that we can look at because the bases can be different, but this parent function that we're going to look at is the graph y equals 2 to the x. So this is an example where the base is 2. Now I already have it graphed on here, and I will kind of point out some important points that we should see in case you're following along and you don't already have this in front of you. So two behaviors that we need to point out. The first one is that if we're growing exponentially, the left side of our graph, or our really far to the left x values, are really, really big. We're moving all the way to the left, and you can see the y values are really close to 0, right? This is our asymptote right here. at the x-axis. I'm going to draw that in with a dotted line. And then as you move to the right, as our x values increase, so do our y values, but they're growing exponentially. So this is exponential growth. Now with the function 2 to the x, there's two really special points that I want to point out. The first one is 0, 1. Now this point is going to be in every single parent exponential growth function, 0, 1. The other one that every single parent exponential growth function has is the point 1, b. Now this is before any transformations. So it's always going to have the point 0, 1 and 1, whatever the base value is. Now here's the really important part. If you're going to write anything down for this section, it's what I'm going to write next. So when we have transformations, now you could totally make a table, that's always valid in math, but it's going to be the really long way around. I suggest using some transformation tips that I have for you to find the two new points after transformation. So if I had this function and I applied a bunch of transformations, then the point 0, 1 is now going to be the point h, a plus k. So using whatever our h, a, and k values are, we can actually find the new, quote, 0, 1 point. Same thing with this one. After our transformations, every single time, this new point is always going to be h plus 1 and then ab plus k. So again, we're applying the transformations. H value affects the x value, and the a's and k's affect the y value. That makes sense because of vertical and horizontal values for h and k. Okay, so now that we know how these are transformed, one more piece that's really important to know about our exponential growth functions is the domain is all real numbers. So if we scan from left to right, all x values are included. And then the range, at least for this parent function, is going to be all the positive values. So it's going to be from 0 to positive infinity. Now, if we reflected this down, so we had a reflection, the range would be negative infinity to 0. So just be the opposite, all the negative values. All right, lots of talking, lots of information. Let's get into some real examples and using these rules to graph our transformed functions. Let's start with number 1. So what I do on all these problems, I've got a few steps I'm going to do every single time. The first one is going to be to list my a, h, and k values, then state the asymptote, and then find my two new special points. So the first thing is first a, h, and k. So a would be the number that's multiplied right here. I don't have a number. That's like having a 1. Our h value is going to be whatever value I'm adding or subtracting to this exponent right here. So for this example, since it says -1, that means h is positive 1. And then my last value is going to be my k value. So if I have a -2 right here, that means my k is -2. So these points are going to help us in just a moment here, or these values I should say, when we find our new transformed points. Okay, so I've got those values listed. The next thing, write what your asymptote is. So I always shorten it. Our asymptote is always y equals whatever the k value is. So y equals -2. So on my graph, I can already plot this. This is the line y equals -2. So at y equals -2, I'm going to draw my asymptote. All right, last thing I would like to do is transform the point 0, 1 and the point 1, well, what value goes there? Look at your function. The base is 3. So that's the value that goes here for the parent function. Okay. I'm going to draw real quick in black what the parent function would look like without any transformations. So it would have the point 0, 1 and 1, 3, and the asymptote would be the x-axis. So we would start at the left, really small values, and then we're going to grow exponentially. But now I'm going to use my rules from above and transform these points. First, I've got the point h, a plus k. So h is 1, and then I'm going to add a and k. that's going to give me -1. So my new point is 1, -1, right here. Let's do it with the next one. So this one is going to be h plus 1, so that gives me 2, and then ab plus k. So I'm going to do a times b, that's 3, and then -2. All right, I've got my next point, 2, 1. So I've got those down. All I need to do now is draw in my exponential growth shape. So we should remember, once we do a couple of these, that this graph is going to be approaching the asymptote to the left and growing exponentially either in the positive direction or the negative direction on the right. So again, approaching my asymptote on the left and then growing exponentially to the right. So in purple or pink, whatever color this is, that is my transformed shape. All right, as we go on, guys, I would definitely recommend pausing the video right when I get to a problem, trying it on your own, and then obviously playing it so that you can see the solution. I'll go through the next couple a little more quickly because we've got a few more problems to do on this worksheet. So the next one, I've got -0.5 times 4 to the x. So I'm going to go through real quick, list my a, h, and k values, and start graphing. All right, so let's see, I'm doing this in green. So a is -1/2, h is 0, and so is k. So there's no shift in this example, no translation. So my asymptote's still going to be the x-axis. I'm going to draw that in, just draw a dotted line, just shows our barrier there. And then let's start transforming the points. So 0, 1. And for this example, it's going to be 1, 4, because again, the base value is whatever this number is, and that's 4 in this situation. Okay, so for the first one, it's going to be h, a plus k, so 0, -1/2. And then for this one, 1 plus h, and then ab plus k. So this one's 1, -2. Let's see what happens when we graph these. So I've got 0, -1/2, and then 1, -2. So you'll notice these lines are underneath the asymptote. That's my clue that this is going to be a reflection down. So again, my graph is approaching the asymptote on the left side and then growing exponentially in the negative direction. Notice that my graph is underneath the asymptote. I can never cross it. That's what an asymptote is. So everything is underneath the asymptote. All right, let's move on to the next page and do some more examples. Okay, so for this example, I've got -2, a base of 2, and then x plus 1 as my exponent. Let's see, this one is a yellow one. So a is -2, h is -1, and k is 0. My asymptote did not change. We had no shift up or down or translation. So our asymptote is still y equals 0. Graph that real quick. Okay, and then let's transform our points, 0, 1, and 1, 2. 2 is our base value. All right, so this one is going to be h, a plus k, so -2 plus 0. And then my other one is going to be 1 plus h, and that's going to be 0. And then we've got a times b, that's -4, and then plus k. Okay, so let's graph these. -1, -2, and 0, -4. So again, all of these graphs are going to approach the asymptote to the left and then grow exponentially to the right. So here's your graph. Okay, next one we have 5 to the x minus 2. I know it's a little small, and then -3. So in blue, let's write our h, k, and a values. So we've got 1, 2, and -3. Our asymptote did change this time. So now it's going to be the line y equals -3. That's going to look like this on our graph. All right, and then for our new points, let's start with 0, 1. After our transformations, This is going to be h comma a plus k, and then our base is 5. So this new point is going to be 1 plus h, and then a times b plus k. So that was 5 and then minus 3. All right, these points are 2, negative 2, and 3, positive 2. Okay, let's get these in here. Growing exponentially. You'll notice this one's a little steeper than the last one because the base is 5 this time, so it's growing a little quicker because as we go from value to value, we're multiplying by 5 instead of multiplying by 2. And that's your graph. All right, we've got 2 more. Looks like I'm doing red next. If you haven't noticed, I have the colorful rainbow theme for this notes. Okay, so this one we've got negative 3 to the x plus 2. So let's go through. A is going to be negative 1, h is 0, and k is positive 2. So that means our asymptote is now at positive 2. Draw that in as I do. Let's find our new points. Base is 3 this time. All right, scooch that over. Okay, so for this point, h comma a plus k, so 0 comma 1. And then for this one, 1 plus h. And then we have a times b, that's negative 1 times 3, and then plus k. That's negative 1. All right, so 0, 1, and 1, negative 1. Notice these are under the asymptote. This is a exponential growth, but a reflection over that asymptote. So underneath the asymptote and then growing down exponentially. All right, last example, I've got 1/4 2 to the x. So let's see what that does for our values. Let's change this to purple. Okay, a is 1/4, or you can write it as 0.25, totally up to you guys. And then we have just 0 for h and k. No shifts up or down or to the right or left. So asymptote is still the same. Let's draw that in. Kind of hard to see because that black line is pretty solid. And then for our new points, we've got 0, comma, and then if we do a plus k, that's just 0.25. And then for this one, it's going to be 1, comma 2. And now it's going to be 1 plus h, a times b, plus k. So when I did a times b, that's 1/4 times 2. It's like 2 divided by 4, and that gives me 1/2. So let's plot these points. I've got 0, 1/4. Just do your best to eyeball it. And then 1, 1/2. So you'll see this is kind of squished down. It's going to be a little more flat than your regular parent graph. Okay, thanks so much for watching, guys, and look out for part 2 where we do some exponential decay functions.